Thank you, Gary. And we want to thank GRC Consultant again for their support throughout all the years. We've known Gary for a long, long time, and he's just a terrific friend and colleague. We have a very innovative session here for you. What we've got are 3 innovative technologies that are just stepping into the marketplace. Our second speaker is Alli Ramey-Ward. She has a PhD in biomedical engineering from Emory University, and she's a research and development manager at ProgenaMatrix Global, and she's from Georgia. And we welcome her. She's kind of, as Rob made the new world, an early investigator to our team, and we welcome the early folks tremendously.
Thank you all for coming to the talks today, and I want to talk today about our new product that we're marketing, ProgenaMatrix, and it's a human keratin hydrogel advanced wound care product. And in general, I just want to talk about why keratin and what makes keratin beneficial for wound healing. So this is my disclosures that I am a paid employee of ProgenaMatrix Global, and I want to thank GR Consulting for inviting this talk. Keratin is a structural protein that's found not just in the skin, but in your hair, your nails, that sort of thing. But we want to talk today about its role in the skin, and it provides cellular strength. So it is an intermediate filament in the cytoskeleton, and it's involved in cell-cell and cell matrix adhesion within the keratinocytes and epidermis. What we also know, if you look at this stained cross-section of the skin, is that there's a protective layer of keratin over the top of the epidermis, and that is sort of the mechanism by which or what we're trying to mimic with our product. So when you have a wound, there's a lot of different things going on, and we've heard a lot of really great talks this morning kind of going over each of these aspects. We have the immune response with the foreign body removal, the tissue remodeling, and the inflammatory response. We have the activation of those dermal fibroblasts to deposit the new extracellular matrix, and then the keratinocytes to reepithelialize the wounds. And these cells also play a significant role in the modulation of that immune response for healing. And there's been a lot of research to show that keratin is actually directly involved in a lot of these processes for healing. In terms of the inflammatory response, it has been shown that keratin can polarize macrophages towards the M2 phenotype. As you can see on your left, work from Mark Van Dyke's group compared culturing naive macrophages on collagen and keratin-coated surfaces. And you see that even at the earliest time points that those macrophages are polarized towards that M2 pro-regenerative phenotype. We see this as well in vivo in the DVDB mouse model. Mouse wounds that are treated with keratin, they have an increase in CD206 positive macrophages, which are those M2 macrophages. And we also see an increase in neutrophil recruitment to the local area of the wound. And we've had some great talks today about neutrophils. But I do want to mention that we have more data relating to this and how the M2 response is not the only response that's going on here, but I will leave that for the poster session later. The next thing that keratin is involved in is activating the cells in the wound bed. And there's been extensive research showing that both fibroblasts and keratinocytes, those key skin cell types, are activated by keratin. You can see that fibroblasts become contractile when cultured on keratin surfaces, and they produce much more extracellular matrix compared to the control collagen products. In keratinocytes, there's been extensive work showing the role of keratin in the healing process as it pertains to keratinocytes, particularly, again, in that cell-cell connection, in the migration and the directionality of those cells in terms of reepithelialization. And what you can see on the bottom there is a scratch assay. It's a little cut off there, but you can see that at the same time point, keratinocytes in vitro were able to heal a scratch wound better than those that were not exposed to keratin. Now, how can we apply keratin as a wound care product? And using biomolecule or extracellular matrix-based products, that's not an innovative technology. We have, there are collagen products, there are amniotic membrane products, various cellularized and decellularized therapies for wound healing, and there are even a few keratin products that exist, primarily derived from sheep's wool keratin in terms of the matrix-type products. But as far as human keratin, there's only been one product so far, and that is a gel. It's not really a skin substitute product. So to this end, I am introducing our product, ProgenaMatrix. This is the first human keratin matrix product, and it is indicated to assist in wound healing by providing a protective covering in a moist wound environment to chronic and acute wounds, dry and exuding, pretty much any wound except for a third-degree burn, we are indicated for. So what we're kind of trying to do is mimic that protective layer of keratin that's over the skin and give it that sort of biomimetic environment in order to promote healing. In that same DBGB mouse model that we've heard several times before this morning, we have the dorsal wound model, and we've treated these mice either with ProgenaMatrix or with another biologically based material, either small intestinal submucosa, amniotic membrane, or bovine dermal collagen. And you can see that the ProgenaMatrix was able to reduce the wound size much faster than these competing products, particularly within the first 3 weeks of treatment. And we heard those talks earlier talking about compliance and people quitting their therapies because they are not seeing progress. So that early closure is really important as far as clinical practice. So this talk is about innovation. So what makes ProgenaMatrix different than any other advanced wound care product on the market? One of the main things is that it's degradation resistant. So keratin in itself is very protease resistant. You can see some data on your right there of the relative keratinolytic activity of various enzymes found in nature. And you can see that very few of them are actually able to even put a dent in the keratin protein. And then at the bottom is some data that we have with our product in both saline and the simulated wound fluid, showing that it is not being broken down over time. And so you might wonder, if it's not breaking down, it's not releasing anything, how does it work? And so our product works by making direct contact with the wound bed. So directly contacting those cells, just like in those other experiments that I showed where the cells are being grown directly onto the keratin, that's sort of the way that our product works. This degradation resistance also allows it to be applied for a longer duration. We talked about patients missing their appointments for various reasons. This product is able to kind of withstand that. We typically recommend weekly changes, but it can stick around for longer. It's not going to be this, 23 applications in 4 months that someone mentioned earlier. It's going to stick around. Another interesting thing about our product is that it's monolithic. It's not a bilayer product or anything like that. It's just a keratin hydrogel. It's just keratin. There's no growth factors that we have detected. It's greater than 99% keratin by proteomics analysis. And it's a unique product in that it is not animal-derived, and it's not a cell or tissue product. So it is human protein, but it's not subject to the human cell and tissue tracking that some other products are. To date, we've seen great success in a number of different wound types being treated with our product. The diabetic lower extremity wounds, also in dermatology with some more interesting wounds, post-surgical, as well as various scalp ulcers and things like that. And then within vascular surgery as well, with VLUs and even sickle cell ulcers, we've seen benefits. And I want to point out the chart here with the study of the diabetic lower extremity wounds. You can see a number of these wounds were treated with another product previously, and you can see that greatly increased healing rate after they've been treated with our ProgenaMatrix keratin products. And so we're not just healing patients, but we're trying to heal wound care and the economic challenges that come with it. So because, as I mentioned, because our product does not rapidly dissolve, this allows for kind of longer intervals between applications. You know, it's not going to disappear after a few days. It's going to stay there and it's going to stay active. We also have a flat rate pricing program to treat large wounds, even in cases where you have the bundle pricing. And we're introducing a new program called Caring Access, where we're providing ProgenaMatrix at no cost to those who are either uninsured or underinsured and can't afford advanced wound care treatments. And our company has dedicated a third of our production to making sure that people have access to the chronic wound care that they need. So to conclude, I hope I've convinced you that keratin plays an integral role, not just in skin biology, but also in wound healing, and that it has emerged as an effective advanced wound care product, and it has been used successfully on multiple different wound types in a number of different settings. And thank you.